Hey guys, welcome back. We're going to start our next part over trigonometry. But before we do that, we need to download an app for a scientific calculator for Android or iOS. I found this one, GeoGebra, scientific calculator. Normally we use TI-30XS multi-views in class. We have a class set and it works out great. We're all using the same calculator. It's phenomenal. But since we're all at home and you guys probably don't have those calculators at home and you guys are going to be using your phones, we all need to be using the same one. So if we use GeoGebra scientific calculator, it's very similar to the one we're going to be using in class, and it's for Android and iOS. So if you guys will go ahead and download those. We also use GeoGebra for a lot of other stuff, so feel pretty safe about using this calculator. So go ahead and download that. You'll probably be using it on your phone while you're using your iPad to do the assignments, so that'll be very helpful. You're not going to want to use the default app on your phone. It does have sine, cosine, tangent. If you are on iPhone, you just turn the default app sideways and you'll see them, but you have to put in the angles first and it's kind of backwards and it's a little bit challenging. So I prefer, and you guys will probably prefer, to use the GeoGebra scientific calculator. If you do have a calculator, a scientific calculator with sine, cosine, and tangent on them at home, like a handheld calculator, like a real one, feel free to use that too. It probably, if it's a TI, it's going to have very similar inputs in what we're doing in GeoGebra. All right, so trigonometry is the study of triangles. It comes from the Greek word trigonon, which means triangle, and metron, which means to measure. Just like geometry means the measurement of the earth, like geometria, same thing with trigonometry. It's the study of the measurements of all triangles. And so specifically, it's the relationship between the angles and the sides of triangles, which is where our trig functions come into play. Now, we've actually already started thinking about this with 30, 60, 90 right triangles. Now, on a right triangle, we need to also be able to name the different sides that we have. So everyone knows opposite of the biggest angle is the hypotenuse. And then the only other part is, what do we call the other two sides that are they're called legs, right? And then of course the joke, what's in between the legs of a right triangle? Well, it's the right angle, of course. So that of course holds as well. So the only other thing is now is whenever we're doing this trig with respect to some angle, which we'll do it with respect to 30 in this case, we need to differentiate between this leg and this leg. We don't call it the right leg or the left leg. That's kind of silly. But instead we call it the opposite leg, because this leg is opposite of the angle, and the adjacent leg, because the adjacent leg is the leg that is next to the angle, but it's not the hypotenuse, because the hypotenuse obviously is the longest one that's opposite of the right angle. So now that we have new names for them, the opposite leg and the adjacent leg and the hypotenuse, now we can do our trig functions. Now with a 30, 60, 90 right triangle, the extended ratio of the angles are 30, 60, and 90, and the extended ratio of the sides is going to be 1 to radical 3 to 2. And notice they're in order from the smallest to greatest to the smallest to greatest, but they are not going to be similar to each other. There's going to be a relationship between them, but it's not a direct relationship. Like there's no scale factor. We're not just multiplying everything by 30 or multiplying everything by 45 or something like that. That would be nice, but it's not quite that easy. All right, then we moved on to our other one, which is a 45, 45, 90. So as we increase this angle from 30 degrees, if we increase it all the way up to 45 degrees, what happens to this side? Well, if we keep the hypotenuse length the same, then we're going to have this new 45, 45, 90 right triangle, and the opposite side is going to increase as well. Just like the opposite angle increases, so the opposite side increases as well. The adjacent side will decrease, and we'll have an extended ratio of 1 to 1 to radical 2, which is what we learned a few days ago. So starting to break down and think about the relationship of how we relate the angles to the sides is where trig came from. It's a very powerful, very, very powerful part of mathematics. It's used a lot in physics, and you'll need it for calculus as well, and it's really good stuff. I think you guys will enjoy. Hopefully you've downloaded that app for Android or iOS. Okay, so the first trig function that we have is sine. So sine is actually spelled S-I-N-E, but it's abbreviated S-I-N. So it's not the sin button, it's the sine button. It's just an abbreviation. So we have three different trig functions that we have: sine, cosine, and tangent. Let me go ahead and pull up the calculator app. So it's kind of scary because as I control my phone, I don't want you guys to see my passcode, but as I control my phone, it shows up on the screen, which is absolutely crazy. All right, so here's our scientific calculator app. So open that up for GeoGebra. And if you notice here, we have sine, cosine, and tangent. those are going to be those are our trig functions. So the first one is sine. It's not the sin button, like I said before. Okay. All right. So the sine, the way that we remember the ratios for sine, cosine, tangent is by SOHCAHTOA. So you might write that down on your paper a few times until you have it memorized, but I'm sure you'll get it down before a few days. Okay. So sine stands for the ratio of the opposite to the hypotenuse side. So the sine, in this case, we always write our trig functions with respect to some angle. So sine of 30 is the ratio of the opposite to the hypotenuse. SOH, sine is the opposite to the hypotenuse, okay? Now the opposite of the 30 is going to be the 1 over here, right? That's the opposite side. The hypotenuse is going to be the 2, which is our hypotenuse. So it's going to be a ratio of 1 to 2. So sine of 30 should be 1/2. So let me pull up my phone calculator again. And so if we put in the calculator sine of 1/2, or 1 divided by 2, that's going to give us, oh, not sine of 1 over 2. Sorry, sine of 30. Okay, yeah, sine of 30 is 1 over 2. Uh-oh, okay, so for noticing on this one, I'm not getting 0.5 like I should. That's because I'm actually in radians instead of in degrees. So yours should default to degrees, so you should actually get 1/2. But let me show you where that setting is. If we go to settings here, angle units of radians, we pretty much in all upper level math use radians, but for now we're going to use degrees, and we don't do degrees, minutes, and seconds. That's like for nautical stuff, but we're not doing anything that cool. So make sure that your angle units are in degrees, and if you're using your own calculator, again, it should say DEG on there, somewhere towards the top on the screen, instead of RAD for radians. So if you got this value, you know you're in radians, you just got to change it. So instead, when we do sine of 30, you should get 0.5, which I got here, so we're good to go. So again, the ratio of sine is just a ratio of the opposite to the hypotenuse, and the ratio for 30 of the opposite of the hypotenuse is 1/2, which is kind of cool. The next one we have is cosine, which is abbreviated COS. Now cosine stands for the ratio of the adjacent to the hypotenuse, which the side that's adjacent to 30 degrees is going to be the one next to it. That's not the opposite one, and not the hypotenuse. And then the hypotenuse would be, of course, the 2. So that's going to be radical 3 over 2. Now again, if I put this in the calculator, I think I just need to touch down here, and then yeah, it will do that. So weird. All right, so if I want to put it in as a fraction, if I want to do radical, I'm going to do the N over D button, right? So I'm going to do radical 3 divided by 2, and that's going to give me this value here. And I'm going to hit enter. I'm going to have to tap there, and then I'll be able to do another one. All right, so I'm going to put this in as cosine of 30. So cosine of 30 should be equal to the exact same thing. Yeah, it's equal to radical 3 over 2, which is cool. Now, no matter how big I blow up or shrink down this triangle, special right triangle, 30, 60, 90, it's always going to have the same ratio of those two sides of radical 3 to 2, which of course you should remember that from our last unit, right? And so that's why the cosine of 30 is still going to be radical 3 over 2, which is the exact same thing. Then the last one we have is a tangent. And as you can probably guess, it's the ratio of the opposite to the adjacent, which is TOA. Tangent is opposite over adjacent. So that's going to be our opposite side of 30 is 1, and then our adjacent side is radical 3. So this is 1 over radical 3. Now typically we would rationalize the denominator, right? So we multiply the denominator by rad 3, so we end up with rad 3 over here. Oftentimes tangent of 30 is actually given to us as radical 3 over 3. Because they rationalize the denominator. All right, so whenever I put this in the calculator, the tangent of 30, and click over here. All right, so we're going to do the tangent of 30, which we should get 0.5777 or whatever. And if we put it in as radical 3 over 3, we get the exact same thing there as well. All right, so let's review our ratios again. So sine, cosine, and tangent is the opposite over hypotenuse, adjacent over hypotenuse, and the opposite over adjacent. So if our x is going to be our angle with respect to x, the sine is going to be the opposite over the hypotenuse. So the opposite of x is a, the hypotenuse would be c. So the sine of x would be a over c, or the opposite over the hypotenuse. Cosine is the adjacent over the hypotenuse. Now adjacent to x is going to be b right here, and then it would be adjacent over the hypotenuse, which would be the ratio of b to c. then tangent is going to be the only other one. So we do the opposite to the hypotenuse, the adjacent to the hypotenuse, or we do the opposite to the adjacent. So it's just the different ratios relating any of the two different sides, right? 2 of the 3 sides. So out of 3, choose 2, which is 3 possible combinations. All right, so that's opposite over adjacent, which is A over B, which would be opposite over adjacent. So anyway, SOHCAHTOA, that's how you remember the ratios of which 2 sides is relating to each other. So our first example, and this is what we're going to be kind of doing on the homework. So on this one, we have 30 degrees, so that's going to be the angle we're going to be we're relating with respect to. And then we have the opposite side of x, and then the hypotenuse is 12. Now, what trig function relates the opposite side to the hypotenuse? So if we look up here, which one does the opposite to the hypotenuse? So it's not going to be cosine because we're not using the adjacent side at all, right? We don't know what this one is, and we're not using the adjacent side. It's not going to be tangent because we're not using the adjacent side. So it's going to be the sine function. So we're going to do sine of 30. That's going to be our trig function that relates the opposite and the hypotenuse. So sine of 30 is the opposite over the hypotenuse, which would be x over 12. Now on this part, we know the sine of 30 is 1/2, right? So that's saying that the ratio should be 1 to 2. And so one way you could do this, which we won't be doing, I'm just showing you this is what's really happening, is we would cross multiply and we would get 2x is equal to 12, so x is equal to 6. Now you're probably thinking there's another way of solving this, and you're right. We could actually solve this with the same method we did before. With the special right triangles, because it is 30, 60, 90. So if I'm going from a hypotenuse of 2 to a hypotenuse of 12, I'm multiplying by a scale factor of 6, right? So this would be times 6. So then what's the 1 going to turn into? Well, it's half of the longest hypotenuse. The opposite is half, right? So it's going to be 6. So x is going to be equal to, in this case, it's going to be equal to 6. Okay, so let's look at another example, but now on this one, notice it's now 29 degrees instead of 30. Well, if it's not 30 degrees anymore, it's not going to be 1/2 like it was before. So this isn't 60 anymore. It's got to be something different. So that, I mean, kind of shows us the limitations that we have for special right triangles. It only works for 30, 60, 90. If it's anything else, even if it's just 1 degree off, it's something different, but we don't know what that value is. But it's okay, the calculator has those values all programmed in them. So we set it up the same. We have the opposite and the hypotenuse, so we're using the sine function. So sine of 29 degrees is equal to x over 12. Now, this is how we'll be setting them up. Now, sine 29 is x over 12. Now, what I want to do is I want to get the x by itself. So I need to get rid of this division of 12. So I'm going to multiply both sides by 12. If I do one side by 12, I'm going to multiply the other side by 12. So these two are going to basically divide to 1 or reduce to 1. So I'm left with x is equal to 12 sine of 29. So let me pull up my calculator, just like I did before. And if you want to get rid of all this stuff, I think you can actually clear all. Yeah, just hit clear all that way. It's pretty simple. All right, so I'm going to type in 12 sine of 29, and that's going to give me 5.8. We'll just use 1 decimal point. So the sine of 29, I guess if I forgot how I set this up originally, but the sine of 29, let me type over there, is going to be the ratio, sine of 29 is the ratio of 0.4848. Now the sine of 30, if we remember that one, was 1/2, right? So notice how the ratio changes. It went down because our angle went down, right? So instead of 30 degrees, now it's 29. So that means the opposite side is now going to be smaller than it was before. And it's going to be the ratio of 4848 instead of 0.5. Okay, so basically, in other words, you could have set this up. All right, 0.48 is equal to x over 12. And then whenever we multiply this by 12, 12 times that will give us our value of 5.8, which is what we had over here. So that should be equal to 5.8, and it is. All right, so let me show you, went too far. All right, so this is a trig table. So if you ask your parents about doing trig, they probably hated it. So I'm just kind of spoilers, but it's actually kind of fun. So hopefully you guys like it. And they might have actually had to look up the values of sine in a trig table. So for instance, sine of 30 degrees is 0.5, but sine of 29 degrees, if I move this up here, is 0.485 or 0.4848 exactly. So all of this is going to be programmed into the calculator. All these values are programmed into the calculator, and that's why we have to use a calculator. But it's not just going to be the integer solutions, but also decimals. Like what about 29.5 degrees or 29.6? So it's actually a function that's actually inputted into the calculator that can use to approximate sine curves. So the sine of 30 we said was 1/2, which is 0.5 here. The sine of 29 is going to be 0.485, which is what we have here. So they're close, but not quite the same. All right, so let's investigate the trig ratios real quick. So this is actually, the trig came from about 300 BC. So our theta is going to be our angle, and then we're relating the opposite to the hypotenuse for the sine function, y over r. Cosine is the adjacent to the hypotenuse, which is x over r, and then the tangent is the opposite over the adjacent, which is y over x. So those values are all here, and here are their ratios of their sides. Now, as I increase this all the way up to 45 degrees, which would be kind of the first one that we look at, so we have 45 degrees, you'll notice that sine and cosine have the exact same ratio because the opposite and the hypotenuse and the adjacent hypotenuse are the exact same values, which is kind of cool. And then the tangent of 45 degrees is going to be 1 because those are exactly the same. Now, if I increase or decrease these values, scale it up or scale it down, it doesn't matter because those ratios are still going to be exactly the same, right? Which is actually really stinking cool. Now, as we increase the angle, you'll notice that those values are going to change. So as I decrease the angle, the sine is going to go down because the opposite side is shorter now. As I increase the angle, the sine function is going to go up because the opposite side is going to increase and go up as well, which is really, really cool. And so if we graphed all of those three out, you would notice a pattern between the sine and cosine. So anyway, those are our trig functions, and we'll look at it again later. All right, so starting the assignment number 1, on this one we want to write the, finish setting up the trig ratios for the sine of E. So E is going to be our angle, angle E, which is this right here, and the sine stands for the opposite over the hypotenuse, which would be opposite over hypotenuse, which is 3 over 5 in this case. Then cosine stands for the adjacent over the hypotenuse. So adjacent over hypotenuse. That's the ratio, which the adjacent side of E is going to be 4. The hypotenuse is 5. So that would be 4 over 5. And you might want to label those. You can label it O, H, and A if you want, or opposite, adjacent, hypotenuse like I've done. Tangent is the opposite over the adjacent. So that's going to be 3 over 4. So opposite over adjacent, which is 3 over 4. All right, let's look at number 2. This one should look pretty familiar because we have 29 degrees again. So we need to label our sides. Well, first I know x is going to be the hypotenuse because it's opposite of our right angle. And then with respect to our angle 29, 10 is going to be the opposite leg. So we're using the opposite and the hypotenuse. So which trig function relates our opposite to our hypotenuse length? So opposite hypotenuse would be the sine function. So we are going to use sine. Also, if you notice, we're not using the adjacent side because we don't know what that one is and we're not trying to solve for it. So we're not going to use the cosine or the tangent functions because they require the adjacent side. So sine function. So we're doing sine of 29 degrees is going to be, our angle 29 is going to be equal to the opposite over the hypotenuse, which is 10 over x. Now make sure you do the order right. It's the opposite over hypotenuse, not hypotenuse over opposite. So be careful there. Now I want to solve for x, I want to get it by itself. So what I'm going to end up doing is multiplying both sides by x, but then I'm going to end up having to divide both sides by the sine of 29. And so there, the shortcut, you're going to end up with x is equal to 10 divided by sine of 29. And there is a shortcut on this one, so let me show you that. So let me just kind of undo everything I just did, and I'll show you the shortcut. You ready for it? Okay, so whenever x is in the denominator, what we're going to end up doing is multiplying both sides by x and divide both sides by sine of 29. So what's going to end up happening is that the x and the sine of 29 are going to end up switching places. So what's kind of cool is you can just move the sine 29 down here and the x over here. Of course, it won't move on your paper because it's paper. But you can just switch those two, and then you have x is equal to 10 divided by sine of 29. Now we're ready to put it in the calculator. So let me pull up my calculator. So let me do, all right, I guess it worked that time. So we're going to do 10 divided by sine of 29. Now, since I'm going to do this as a fraction, we're going to use the n over d button, which is going to do it, basically input it as a fraction, to make sure that you did it right. So 10 divided by sine of 29. and that'll give you your answer, which is 20.6. And that should be one of your answers on the answer bank, so we'll use 1 decimal place, I believe. All right, number 3, we need to label our sides with respect to 46 degrees. So we have the opposite side as x, and then the adjacent side, which is the one next to it, that's not the hypotenuse. And if you notice, we're not using the hypotenuse on here, so that means we can't use the sine function and we can't use the cosine function. So which trig function relates the opposite to the adjacent? Well, that's TOA, tangent. So we are going to do set up your equation. Tangent of 46 is equal to the opposite over adjacent, which is x over 7. Now I want to see on all of your paper, I want to see you set this up. Don't just put it right in the calculator. I want to see you set up tangent of 46 is equal to x over 7. Okay. Now from there you can show your work. It's not that hard from there, but I do need to see at least how you set it up initially. Next thing I want to do is I want to get the x by itself. So I want to multiply both sides by 7. So whenever I do that, this is just going to divide to 1. So I have x is equal to 7 tangent of 46. So that's what I'm going to put in the calculator. So I'm pulling up my calculator here. All right, nice. I'm figuring it out. So 7 tangent of 46. Okay, cool. And I get 7.24, which will round down to 7.2. And that will be your answer. All right, on number 7, my angle is 52 degrees. I need to relate these two sides to each other. So the opposite side is going to be 6 feet. The adjacent side is going to be x. And if you notice, the one that I'm not going to be using is the hypotenuse, which means I'm not using the sine function or the cosine function. So instead, relating the opposite to the hypotenuse would be the tangent function, which is TOA. So I have tangent of 52 degrees is equal to the opposite over the adjacent, which is 6 over x. All right, then if you notice, the x is on the bottom, so we have our shortcut, right? I can switch the place of those two. So x is going to go over here, tangent is going to go on the bottom, and that's going to give us x is equal to 6 divided by tangent of 52. Now all you need to do is show me how you set it up here, and you can draw the arrows telling me that you're switching it, and that's good. You don't have to rewrite the whole equation, but do remember whenever, I'm going to redo it, it's kind of funny, whenever you put it in the calculator, so we're going to do 6 divided by tangent 52. So here we're going to have 6, oh, make sure you do the fraction button again, 6 in the numerator. Denominator is going to be tangent of 52, which will give us 4.68, which will round to 4.7. All right, number 8. So it's kind of cool because it's a real world example with a diagram of a tree and a ladder leaning against a tree. We have 67 degrees here. We want to find out the length of how high the ladder goes up the tree. So to figure out that part, that value is going to be x in this case. Now we need to label our sides. This is going to be the opposite side of 67, and this one would be our hypotenuse. So I need a trig function that relates the opposite to the hypotenuse. And if you notice on this one again, I'm not using the adjacent side, so I can't use cosine and I can't use tangent. Instead, I'm going to use the sine function because it relates the opposite and the hypotenuse, opposite and hypotenuse. So finish writing your trig function. We're going to do sine of 67 degrees is equal to the opposite, which is x, divided by the hypotenuse of 13. So I want to get x by itself, so I'm going to undo division with multiplication, so multiply both sides by 13, which will be 13 sine of 67. So that's what I'm going to put in the calculator. So let me go ahead and clear all this because it's kind of getting annoying. All right, so I'm going to do 13 sine of 67. Okay, so 11.96, which will round to 11 or 12. I think I used 2 decimal points. You get it. 11.97 if I round. All right, number 11, we've got our angle. We have over here the opposite leg, and then here we have the adjacent leg. The one I'm not using is the hypotenuse. So if you need to think of it that way, I mean, it works. So the only one that I can use would be the tangent function, right, which relates opposite to the adjacent. All right, so tangent of 36 is equal to 20 over x, opposite over adjacent. And again, we're going to switch the order of these two. So just set it up just like I did here, and then show me that you're switching the order, and then put it in the calculator. So we're going to do 20 divided by tangent 36. So that would be, make sure you do your fraction button first. So 20 divided by tangent 36. All right, so that's going to be 27.52. All right. Number 13, with respect to 61, we need to label our sides. So this is going to be our opposite side. Here we have our adjacent, and the one we're not using is the hypotenuse. So I'm going to cross that one out. Which trig function relates the opposite to the adjacent? Opposite adjacent would be tangent. So we're using our tangent function again. Tangent of our angle of 61 is equal to x, our opposite over adjacent, which is x over 9. So then we multiply both sides by 9. And again, that's going to divide to 1. So we get 9 tangent of 61, which is what I'm going to put in the calculator. So we have 9 tangent of 61. Okay, cool. 16.24. All right. Number 16. Again, label your sides. If you notice, it's the same process over and over again. And when we get over here, we either have the x on the bottom or the x on the top. And if it's on the top, we multiply. If it's on the bottom, you switch them. So once you kind of get the routine of how to set it up, trig's really not that difficult. And all the trig functions are programmed into your calculator. So it shouldn't be that bad. So we've got the opposite. We got the hypotenuse. What trig function relates those two together? Opposite and hypotenuse would be our sine function. So we set it up, sine of 25 is equal to 3 over x, opposite over hypotenuse. When x is on the bottom, we switch the order of the two. So again, just draw your arrow saying that you're going to switch those two, and then put it in the calculator. So 3 divided by sine 25. All right, so fraction again, 3 divided by sine 25, which is going to give us 7.10 if we round. 19. On this one we have two angles, 32 and 58. So we could actually set this up two different ways. Let's set it up with the 58. So I don't mess up, I'm going to actually go ahead and cross out the 32 just for a second here so that I'm doing it with respect to the 58. Alright, so if I do from respect to the 58, we've got the opposite and the hypotenuse, which would be using the sine function. So sine of 58 is equal to 8 over x, and then I would switch those two. All right, now if I wanted to do, well, I'll go ahead and put that in the calculator. So 8 divided by sine 58. So as a fraction, 8 over sine 58. All right, so we get 9.43. Now, if I do the same thing, but now I'm going to do it with respect to the 32 degrees, how does this change? Well, now this is no longer the opposite side. Now it's the adjacent side, right? This is still the hypotenuse. So which trig function am I using that relates adjacent to hypotenuse? Well, it's going to be the cosine of 32 this time. It's going to be 8 over x. And then again, I'm going to switch the order of those two. Now what's cool is that these two, they're actually related to each other. They're complements. And so whenever I put this in the calculator, it's going to be, as a fraction, 8 over the cosine of 32. Which is exactly the same as 8 over the sine of 58, which is cool. So if you are given two angles, you can choose whichever one you want. What I recommend is choose one of the angles and cross out the other one so you don't accidentally switch halfway through the problem. All right, so that's it. If you guys have any questions, please let me know. Try to do my best with the calculator and all that stuff. If you use the same calculator I'm doing in the video, which everyone has access to because it's free and it's on Android and iOS, then we should be good. If you have any other questions, I can try to help you with that. If you're using a different kind of calculator, you might have to, I don't know, Google it and figure out how you input trig functions with that specific calculator. So if you have any questions, let me know. If not, I'll see you guys later. Have a good day.